A little bit about me. I've lived in this hell city for 12 years now. Moved here in 2007. I worked at Google. I worked on the ads quality system. So you already did a search on Google and ads showed up. That was me, kind of roughly 2008, 2009 timeframe. You're welcome. Terrible. Worked on a lot of Google's data infrastructure my last couple of years there. And then I went to work at Cloudera. I got tired of commuting down to Mountain View, decided to commute to SFO instead, and became the director of data science and flew all over and gave talks and that kind of thing. I told people about Hadoop and MapReduce and Spark and all that kind of good stuff. Did that for a few years and then decided I wanted to get a real job. So I went to work at Slack as the director of data engineering in 2015, October 12th, 2015, as a matter of fact, which was just about 4 years ago. I did that for a couple of years, discovered I did not like management very much. My story about management is there's this old sort of hoary chestnut about law school, where law school is a pie eating contest where first prize is more pie. And I felt roughly the same way about management. You kind of just like look up the management chain, you're just like, wow, there's a lot more pie up there. Anyway, and then I was a Slack engineer, and you don't see it on there because it's cut off now, but I just became a regular, honest to God, just software engineer. And I did that the last 2 years, and excitingly, last Friday was my very last day at Slack. Thank you. I am an unemployed speaker at a machine learning conference. And the recruiters just pounce. Yeah, so I'm just gonna run for it after this talk. Couple of questions I get all the time. How does it feel? Oh, it's okay. It's nice to be free. Nice to be free of the system. It feels pretty good. I've only been doing it for a week or so ask me in a little while. I did have a moment on Tuesday where my son was at school, and I finished this talk like 3 days early, which is basically about 3 days earlier than I have ever finished any talk. And I was like bored for an hour. I had an hour where I had like nothing to do. And it was very weird and very uncomfortable, and I did not like it. So we'll see how long this lasts, broadly speaking. And the next common question I get is, what's next? Josh, what are you gonna do next? And I don't really know. The answer is mostly nothing. I don't have any plans. I'm not going to go do anything. I consult, obviously, the Silicon Valley hierarchy of needs, always a good resource to turn to. I think I'm going to travel the world, probably going to do that for at least a little bit while, and then I will be back writing Medium blog posts with life advice for others. So I'm pretty stoked to climb to the very pinnacle of that hierarchy. This talk is in some ways like kind of preparation for my future Medium blog posts. So sorry about that. Yeah. All right. Quick outline of the talk, which is, like most of my talks, contains a lot of tweets. We're going to do a brief sort of summary of my personal life, and then we'll talk about my startup for a little while. And after the talk is over, at the after party or whatever, we're having drinks later. If you'd like me to speak for 3 hours on my unique and contrarian take on the WeWork IPO, I would be happy to do so. All right. A little bit about me. This was my Monday. My son and I went to the Oakland Zoo, and I got some of this stuff. Daddy, are you having a good time? Yes, I am. Me too. Oh, that's like the best stuff ever. That makes almost all the sleep deprivation for the last 4 years worth it. That's like super great. It's going to keep me going through parenthood for another couple of years. All right, that's plenty of time in my personal life. Let's talk about my startup. There's a very common, like a cliche, and it's a cliche because it's true, which is that you have a person who worked at a company for a while and they leave. They have a very natural instinct to do a startup that is basically like the feature they wanted to work on at the last company, but could never convince anyone to work on, right? Everyone kind of familiar with this cliche, right? And it's generally like, it's a cliche for a couple of reasons. One, I mean, if they had successfully convinced the company to work on it, well, obviously they would still be working there, right? They'd still be working on it. And it's generally a terrible idea, almost always. And it's a terrible idea because they did not successfully convince anyone at the company to work on the idea. I have a few of these ideas. I need to get them out of my system. That's what this talk is about, roughly speaking. Before I go any further, though, Slack. Does anyone here not know what Slack is? Are there any Google employees in the audience? Poor Google employees. I once actually bumped into a former Google colleague at the Cal Academy, and I told him I worked at Slack, and he got like super excited. And he was talking about all this exciting stuff that Google was doing with Slack, and I was just kind of like super confused. And then I realized about halfway through the conversation that he was talking about the Stanford Linear Accelerator. nuts. These people just live in a bizarre world. Anyway, this is Slack. Slack is basically, if you don't know, it's like Kafka, but for people, roughly speaking. There are these things called channels. They're kind of like topics. You can post messages to them. You can read messages from them, that kind of thing. First terrible startup idea. Hear me out now. It's like Slack, but for Jupyter notebooks. Nothing. Okay, good. All right, cool. All right. Not even sure what to do with that. If you would like to start that company, email me. I'll give you like $25,000 just to kind of get you started. I would really like this to exist. Is it just me? I don't know. Okay. It's just me. All right, this is good. This is why we do this. It's cleansing. It's important. Let's continue. When I became an engineer at Slack, I worked primarily on search. I worked in particular on rebuilding all of Slack's search infrastructure. Does anyone remember like Slack search, kind of circa 2017? When a query would take like 5 seconds? Yeah, a few people. Like, yeah, a few hands go up, right? That's terrible. Yeah, so I worked on fixing that. You're welcome. It's an interesting story, like that kind of stuff. All of my other ideas for terrible startups are generally in the space of search and enterprise search. And the good news is that I don't actually have to start a company to do this because there are, as far as I can tell, about half a dozen companies right now doing some kind of AI enterprise search thing. And I know this because they have all tried to hire me. And when this sort of the rest of this talk for me is really like my advice based on like what I have learned about working on like search and search ranking in an enterprise context for the past couple of years. First and foremost, show of hands, how many people here feel like Slack search is good? Thank you. This is really very kind of you. This is very, see like the generous and empathetic people in this audience. Okay, thank you. Slack search is actually not good. That's nice of you all to say. That is not exactly true. Slack search is actually quite good, but it's good at really exactly one thing, which is finding, is basically recall. It's finding something that you know exists, where you have some semblance of the idea of like what it was you were talking about. Like you have some, you know some words from the message that you're looking for. For context here, before I left Slack, some of my coworkers set up a new kind of like JWill's random channel, which just pipes my tweets into it. So like Slack has my tweets kind of in a channel, so people can just, I don't know why they did this, but they did this. And it was super helpful for me because I was trying to find that sort of that Tech Boys WeWork kind of tweet thing, which to be fair, we spent a lot of the last 3 months dunking on WeWork inside of our random channels, like many of you have, I would assume. So I wanted to find that tweet. I couldn't find it. Google wasn't helping me. Twitter search wasn't helping me. So anyway, I went and posted this, and one of the search engineers at Slack went and found it for me and gave it to me, and I got to use it as the outline for my presentation. So that was like super helpful for me. So when you know what you're looking for and you know it exists, Slack search is great. That's fantastic. But what it is not Google search. It is not Google search. And I want to talk about why that is. And I think the thing that really, I did not work on search at all at Google. I worked on ad stuff. I've only really ever worked on search at Slack. But I got to sort of like, working on search at Slack gave me a profound appreciation for just how easy Google's search problem is. Yeah, that's right. I went there, Google people. Your problem is easy. And this is why, right? So at Google, the corpus is the web, and the queries and the corpus are all like public. So I, Google engineer, can like basically find someone's query, go type it in myself, and see all the results that come back, and see if they're good or see if they're bad or blah, 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 blah. And at Slack, that is not true. I will totally answer questions later, I promise. I cannot see anyone's messages, and I cannot see anyone's queries. I have no idea what your messages are. They're your messages. They're not mine. I don't get to see them. They're your queries. They're not mine. I don't get to see them. They're not public, right? So I have no idea. Second, Google has lots and lots of head queries, nav queries, Facebook, YouTube, blah, 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 blah. Lots and lots and lots of Google's queries are super, super well defined. They know them extremely well. Slack, that is the exact opposite. Almost every query at Slack is unique. The head queries at Slack is basically stuff like Wi-Fi password or GitHub. I mean, thanks to Pantslow there, chat. GitHub? Really? I'm supposed to work with that? There's almost no head queries at Slack. Almost every query is unique. You have like exactly one observation for it. And finally, web pages want to be found. They want to be found so badly that Google has like a whole spam team that's designed to get rid of the pages that want to be found a little too badly. And at Slack, that's not true. Messages don't care about being found. No one comes along later and puts like keyword tags on messages to make them easier to find, generally speaking. Messages don't care about being found. They're not like out looking to be found. So this is like the sort of baseline set of problems, and it's where Google has things, in my opinion, relatively easy compared to enterprise search problems. All right. The other problem Slack has. When in doubt, if search fails, you can always fall back on like sending a DM or posting in a channel or something along those lines, right? Whereas Google, if Google search fails, you're kind of SOL. There's not like anything else you can do. If Google can't find it, and what that means is you're gonna stick with it. You're gonna like keep banging away and trying to find the magical combination of keywords that gets you what you want from Google. And Google can use that information to train better models. At Slack, I can't really tell if you do a search and like didn't click on anything and then went and DM'd someone. Were you asking them a question about the search you just did? Were you like, is the answer they give you the right response for this search, or was it some completely unrelated thing? I have absolutely no idea. And so having the social fallback prevents Slack from getting all of the training data they might be able to get, or at least that Google will be able to get for someone who's desperately looking for an answer. Not for nothing. This whole problem of like DMing people for answers to questions that you like are like easily available in the Slack search history is a large contributor to the noisiness of Slack. I mean, let me Slack search that for you or something like that. That's kind of like a lot of what stuff is. It's, you know, in terms of like Slack and machine learning, there was kind of this dream and this vision that we would build a chief of staff for everyone. Every person would have a chief of staff to kind of help find you the information that you need to know and like filter out the extraneous noise and all that kind of good stuff. I don't want a chief of staff, y'all. I want a customer service agent. That's what I want. I want like a bot that just handles my incoming DMs. And if whatever it is the person is asking for is like available in a message I have posted somewhere else, just link them to the answer. Let me Slack search that for you. Let me just send you the result directly. That's what I want. All right. So how did Google make search good? How did Google make search good? This is the Google search results page for logistic regression right now. And this is phenomenally rich, right? They have just like lifted some snippets right out of Wikipedia. There's a knowledge graph entry over there on the right. There are related questions. Google's really gone from a world of like 10 blue links, which is how they used to think about the search result page, to, well, one blue link, exactly one, which contains the right answer. They have like uplifted all of the useful information from the search result page, from the like search results onto the search results page itself. And this is fantastic, and it's created this very, very high bar for search experience that people are trying to meet. And they can do this because all of Google's technology, all of its power, all of its stuff that they built is built on top of an enormous corpus of very high quality click data. That's really what it is, right? The sort of the click results for queries like logistic regression and so on and so forth are so stable and so perfect over time that Google knows exactly what the right answer is going to be, and they can pretty much just up-level it and give it to you directly on the search result page. And this sets a very, very, very high standard that is difficult for any enterprise search startup to meet in any kind of credible way, especially when they do not have reams and reams and reams of high quality labeled data to build their systems on top of. And this is important because in many ways we are living in a machine learning, like at least in industry, we are living in a machine learning universe that Google has created. We build on top of high quality data sets, like high quality labeled data, or we don't like build at all. There was a Twitter conversation I was having with Russell Journey and Pete Skomarok about this, which basically data labeling is a good proxy for whether or not machine learning is cost effective for a problem. If you can get high quality labeled data, you basically have a shot. You have a good chance of solving the problem. We have amazing, powerful technology that can be applied to sort of like strongly supervised, high quality labeled data. And if you don't have that, like you're basically screwed. There's like nothing you can do, more or less, right? Without a large amounts of this data, it's just simply not possible to solve these problems at all. And as a result of this, what I find as like we approach machine learning problems is an over-reliance or an assumption. We are overly reliant on imperfect but voluminous and easily obtained labeled data. And the example of this I want to give is like at Slack search. So Slack has a very significant amount of click data on search results, right? We definitely see when you do a search and you click on a message, that is information that can be used to train a better ranking model. But it's not the only source of information that can be used. In fact, a much more useful source of information about the quality of a search result is whether you share the search result into another channel. The single most positive signal for Slack search is if you find a message from search, you click on it and you copy it into a channel or share it or whatever, that is almost always a positive signal that you have like a very, very good search result. So we basically try to combine these kind of like fairly imperfect labeled data sources together to come up with kind of a synthetic, hard, strong supervised signal of what the best possible what the best possible answer is for any given user's query. But this is a highly, highly imperfect process. And Slack, and I think a lot of other enterprise search startups, would be well served by like explicitly asking for people's feedback. Is this a good search result? Like thumbs up, thumbs down, X stuff out, all that kind of stuff. This would be like incredibly, incredibly useful. But it's also kind of counter to the user experience that Google et al. Have sort of trained people to expect. Like Google expects this stuff to happen magically because it kind of does happen magically. Like the thing that you want from Google is to like click on an answer and go away, and Google is very good at helping you do that. All right. Where I sort of started like kind of thinking about this problem in a new way was when I was working on I guess like all of us were working on a new spam detection model for Slack. Slack has this invite functionality. If you're creating a new Slack team, you can invite people to the team. And inviting people generally involves sending them email. And just, as everyone knows, if it's possible to send email anywhere on the internet, that will become a spam vector. It's just basically guaranteed. And that is very much true for Slack as well. So as a result, we have a bunch of rules and like sort of simple classifiers we use to detect spammy looking invites. I'll throw the spammers a bone. If you include the word bonus in Russian in an invite, it's pretty much spam. Pretty easy one. It's a certain set of domains that are, again, same kind of thing. It's pretty much spam. And so we decided to build a better spam classifier system using all of this powerful machine learning technology we had created that we were familiar with from our days at Google, Facebook, Airbnb, all these kind of good places. And our thought was to basically use a easily available, highly voluminous signal to train this data. And the signal we decided to use was basically the invite acceptance. Was the invite, someone sends an invite, was the invite accepted within like 3 days or something like that? So yes, good email, no, bad email. I try to basically predict whether the email is going to be accepted within 3 days or not. So built a model like this, applied all of our sort of very powerful, high dimensional feature extraction logic to it, and we ended up building kind of like a comically bad model. In fact, my favorite feature this model discovered was that the number one spammer of Slack invites was Slack's VP of engineering at the time, Michael Lopp, who has also since left Slack and is in this kind of strange pseudo retirement state that I find myself in, because Michael Lopp, he goes by Rands. If you've ever seen his blog, it's called Rands and Repose, and he runs this like fairly prominent engineering leadership Slack, which you can get an invite to, and he invites lots of people to. But then you find out that it's actually the whole Slack is just full of engineering managers, and then you're like, whoa, maybe I won't join it. Maybe that's a bad idea. Okay, I need to work on that joke a little bit. That's fine. But like anyway, this was sort of the thing. We built a model on an easily labeled data source that wasn't exactly the thing we wanted to train against. We really wanted to train against spam, not necessarily not accepting an invite. And that caused a problem for us when we brought kind of like the baseline machinery that we had available to us from our Google, Facebook, Airbnb days to bear on this problem. And so working on this got me thinking about other possible modalities, like how else could we tackle this sort of stuff? And that's sort of like my big question and my big challenge. And I think it's what I've loved about being here today is like everyone is talking about this. How do we get good labeled data? I use the analogy of Tom Sawyer like painting the white fence, more or less. How do I trick, actually all of you into caring about labeled data? Like that's kind of the challenge. That's the interesting machine learning problem. How do we make labeling data kind of fun, if anything? Like worthy of conference talks, that sort of stuff, not something that's terrible. For the invite spam problem, the tool we used was something called Snorkel. So we had all these rules, we had all these like sort of simple classifiers. Anyone here familiar with Snorkel? Snorkel comes out of the Dawn project at Stanford, which is about democratizing machine learning and making it available to people. And the core notion of Snorkel is supporting the idea of weak supervision. So instead of having this single kind of strong label predictor that we're very, very confident in, we have a whole bunch of kind of like not so great, sort of crappy heuristic predictors that are maybe kind of related to what we're looking for, but like not perfect. Exactly. And that's kind of like what we have when it comes to spam, and that's kind of what we have when it comes to like Slack search in a lot of ways. We have a lot of different signals, none of which are perfect. But what we can do is use Snorkel as a tool to combine a bunch of imperfect signals together to come up with a probabilistically labeled data set that gives us some idea of like what sort of like the ideal training data would be for our model with some sort of notion of like statistical significance and confidence in what we're doing. What it really does is it takes a whole bunch of these things called labeling functions. Labeling functions are basically a labeling function looks at an observation, it makes a decision, it can say I will predict this to be X, I will predict it to be Y, or I will just not predict anything at all. It generates this sort of large kind of like label observation matrix, and then it runs some statistics to kind of boil things down into a single probabilistic feature that can be, or single probabilistic label that can be fed into logistic regression, XGBoost, a deep neural network, kind of whatever you want. And the result of doing this is generally better models than you would get if you actually assumed that your sort of noisy data was like the real truth, since it's generally not. Even more exciting than this is a new project. This actually just came out a couple of months ago, so I've not gotten a chance to play with it, but it's very cool. It's called Snuba. So Snuba is this idea where you don't even actually have to generate these kind of heuristic labeling functions yourself. Generating the functions requires some Python. Better than that, you can actually just give a small sample of some observations to experts, have them hand label them, just a very tiny sample, and Snuba will auto-generate heuristic functions off of those labeled observations from experts, and then feed them into the same kind of machinery that powers Snorkel to, again, come up with a probabilistic data set. What it allows you to do is leverage a very small quantity of a very small amount of high quality label data to generate significant amounts of training data for a much larger data set that you can, again, feed into all the machinery, the big data sort of machine learning stuff that we're all sort of getting used to using. And I'm excited about this because it means that we can take a small amount of data hand evaluated by Slack or taking a small amount of explicit feedback from people and then sort of in a principled and scalable way integrate it all together to provide a good foundational signal that can be used to train all of our sort of subsequent data. They call this paradigm data programming, and I actually kind of like very much like that. And the one sort of like thing I would recommend to anyone who's interested in these methods or interested in looking into them is that once you're doing data programming, you very quickly need essentially data version control. Because you will have observations that are labeled against some subset of the features, and then some new observations come in later, and some new features come in later, and all this kind of stuff. So if you're into this kind of stuff, there's a guy here named Tim Sen, who's a friend of mine. He works on a project called Dolt. Dolt is basically Git for data with SQL on top of it, and it's just kind of awesome, and I highly recommend checking it out. It's like really useful for when you're generating all these different like hand-generated labels to have proper version control and branches and all that kind of stuff to manage the generation of your training data and manage its labeling and all that kind of good stuff. All right. But BERT. Google came out a couple weeks ago with this new BERT-based, this new embeddings-based system for handling the long tail of queries that their ranking models cannot handle very well. BERT, XLNet, all this kind of good stuff, all the embeddings work that's happening right now in NLP is super exciting. It's incredible, right? This stuff is getting so good so fast in ways that like people are not really recognizing, or like the general population outside of this room doesn't even realize that's happening. It's really cool. It's really powerful. It's worth checking out and learning about this stuff. But what I want you to do is stay focused. I want you to stay focused so badly I use the distracted boyfriend meme. That's how badly I want you to stay focused. Stay focused on high quality label data. Google gives BERT away for free. They don't give the labeled like click data away. This is not a coincidence. One of these things is incredibly valuable. The other one is a commodity. It's available for everybody because it doesn't like sort of fundamentally drive the business. If you're doing a machine learning startup of any kind, if you're doing machine learning in your company, your high quality labeled data set that you construct from a bunch of like weak heuristic rules, that's the IP. That's the valuable bit, not the embedding model, not whatever implementation of not your TensorFlow or your PyTorch architecture. It's that high quality labeled data. That's the valuable stuff. So protect it, focus on making it really, really good, and let me invest in your company. And with that, thank you all very much. I appreciate it.